Alright, so here we go. We've got questions 6 and 7. The ball comes in at an angle like this and then leaves at an angle like that. And so it's got a 30-degree angle here, 30 degrees, and then a 30-degree angle here, 30 degrees. Okay, now the thing you have to take into account first off the bat is that there is a x component and a y component coming in, and an x component and a y component going out. Alright, conveniently, since it's 10 meters per second, alright, so the mass or the velocity is 10 meters per second. Whoops, let me erase that real quick. It's both of them are 10 meters per second, we can assume. So that means that it's going to be fairly easy to break up. So if you just find it for one of them, you found it for both of them. So Vx is 10 cosine 30, and Vy will be 10 sine 30. And so if we do this real quick, Vx is equal to, sorry, let me get my calculator working. 10 cosine 30 is 8.66, and 10 sine 30 is 5. Alright, so why did we have to do that? Well, it's because since it's at an angle, it changes things a little bit. In the x direction, you'll notice that it's 8.66 to the right, or sorry, to the left, and then again 8.66 to the left, right? So nothing changed in that one. There was no change in what happened. It was still to the left. So if we did momentum in the x, the change in momentum in the x, it would be mass times 8.66 minus 8.66, which would be equal to 0. So there was no change in momentum in the x. Now, in the y direction, however, we do have some change, because it comes in, the mass, by the way, was 2 kilograms, and it comes in at 5 this way and comes out at 5 that way. So you notice that one is positive and one is negative. So the final velocity is negative 5, and the initial velocity is positive 5. So we do change in momentum equals m vf minus vi. That's what we're doing here. And so that equals, change in momentum would equal 2 times negative 10, or negative 20, should be negative 20 kilograms meters per second. So that is your change in momentum. Your change in momentum in the x is 0, but your change in momentum in y is negative 20. So there is that change in momentum. Now you notice this is different, by the way, than if we had just done change in momentum equals 2 times 10 minus, or negative 10 minus 10. That would be a change in momentum of 40, which is not the answer. So we need to make sure we break it up into components if it's at an angle. Alright, next we have the two objects that are moving one's moving, a 2 kilogram object is moving east at 4 meters per second, and a 1 kilogram object is moving north at 6 meters per second. So after the collision, we can assume that these two objects are now stuck together and moving in some direction this way. Okay? But what we have to do is, this is a momentum that they will have, right? We're looking for the velocity. So our goal here is to do P is equal to mv and figure out what the velocity would be, because we know what the mass would be. It would be 2 plus 1, which would be 3. So the mass final is going to be equal to 3. We're going to be looking for the velocity final. But in order to find that, we have to know the momentum final. So how do we calculate the momentum final? Well, that's a good question. What we have to recognize is that there is a x momentum here and a y momentum here. Okay, so we got px and py. Now, where do we find px and py? Well, we have to look and remember that in the x direction, the only thing acting in the x direction is the green, or the 2 kilogram box. It's the only thing acting in the x direction. So the momentum in the x should be 8 Newton seconds. And the momentum in the y should be the only thing in the y, which is this orange box, which would be equal to 6 Newton seconds. So then that means that this is 6 and this is 8, which if you do the Pythagorean theorem and do PF equals 8 squared plus 6 squared square rooted, you would get PF equals 10 Newton seconds. Alright, so that's how you calculate it. Now the reason that is, again, is because this is the only thing acting in the x and this is the only thing acting in the y. And so that the green is the only thing contributing to the momentum in the x, and the orange is the only thing contributing to the momentum in the y. So they add together to equal the final momentum of 10 Newton seconds. So now we know the momentum is equal to 10 Newton seconds, so we can figure out what the velocity final is, because we know that the mass is 3. So we divide by 3 and we get the velocity final is equal to 3 1/3 meters per second. Alright, and that is the momentum review. I hope this helps everybody that watches it, and good luck on your test.